Hey everyone, Professor Hank here. So today we're going to talk about inheritance in Java. We'll talk about what it is and we'll see an example of it, and we'll also look at how we can diagram it in UML. So let's begin. What is inheritance? Inheritance is a way to model the is-a relationship in an object-oriented programming language such as Python, C++, or Java. And what it allows us to do is take an existing class and extends its functionality through a new class. And we'll be able to inherit all of the functionality of the original class in the new class without having to rewrite all of the code. So this is a very powerful tool and can save us a lot of time and allow us to reuse existing code. So let's see an example of it. So we'll go ahead and create a new project, and I'll just call this project inheritance demo, and we'll just name our package stuff. So we'll create a class called rectangle, which is going to serve as our base class or our parent class. And then we'll create a second class which will inherit from it. So let us add a new class to package stuff. So we'll do new Java class, and then we'll name this rectangle. And we're going to add to our rectangle a couple of attributes. So we will have a private double for the length, and we'll have a private double for the width. We'll include a constructor, public rectangle, and this constructor will be a default constructor because it has no parameters, and we'll just use it to initialize length and width to 0. And then we'll add a couple accessors and mutators for updating length and width. So public void set length double L, this.length equals L. And then we'll create a set width method that will do pretty much the same thing. Set width double W, and then we'll have a couple of accessors. So we'll do public double get length and return this dot length, and then we'll have public double get width, and we'll return this dot width. And then finally, we'll add one more accessor, which will be get area, which we will see more of in a bit. So to get the area is just returning the length times the width. So in this example, this is going to be our base class, also called a parent class. So those are kind of synonymous. So what we're going to do is we're going to have a rectangle, but we're going to make a new class based off of our rectangle. Now the rectangle class is its own fully functioning class. So we can instantiate an object that is a rectangle, and we can manipulate its length and width and go through its public interface and all that stuff just fine. But let's say that we wanted to add something to it. All right. So let us say that we wanted to create a solid. They can have a third dimension, so depth. So if I wanted to create a class like that, I could take all of this stuff, copy and paste it into a new class, and then add another variable for the depth, and then accessors and mutators and all of that. Or I can use inheritance. So to use inheritance, I'm going to create a new class, and I'm going to have to use a keyword extends. So I'm going to name this class solid, and then I'm going to just add it. And in here, what I'm going to do is I'm going to need to add to my class header here the keyword extends and the name of the class that I'm inheriting from. So class solid then becomes a subclass or a derived class or a child class of rectangle. Further, since this is modeling the is-a relationship, a solid is a rectangle. So everything that a rectangle is, a solid is also, but that relationship doesn't work in reverse. A solid is a rectangle, but a rectangle is not a solid. Just like you inherit traits from your parents, they don't inherit traits from you. So what we're going to do is to our solid is we're going to add that variable for depth, private double depth, and then we're going to add our accessors and mutators. So we're going to do public void set depth double D, and then we are going to do this dot depth equals D, and then we'll add an accessor, public double get depth, and then we will return this dot depth, and then we'll add a constructor. So we'll have public solid, and then we are going to just set the depth to 0. Now, because a solid is a rectangle, it is everything that a rectangle is. So we're going to get the set length, the set width, the get length, the get width, the get area. So we'll be able to access those and execute them from a solid, even though we didn't rewrite all of that code. That's the cool thing about inheritance. So let's go into our static main here, and let's instantiate first a rectangle. So we'll do rectangle r equals new rectangle. And so that'll create a rectangle object, and then we can do r.set width, and we'll do 1.2. Then we can do r.set length, and we'll do 0.75. And then we'll print out the area, r.get area, and then we'll check that out. we'll see that that works just fine. It is a class in its own right. A rectangle is a rectangle. So we've defined our rectangle to have a set width, set length methods, also this get area. And so then you can see there's the area right there. Now, since a solid is a rectangle, it'll have access to set width and set length and get width and get length in addition to everything that we gave to it. So it's everything that a rectangle is and more. So let us create a solid, and then you'll see I can do s dot set width 1.1. So I'm using set width. Where is it in here? I didn't have to rewrite the code because I inherited it from the parent class. Okay, so I also inherited the ability to set these variables because I have the set width. So I can do that. I can also do s dot set length, say 2.2. But in addition, my class solid also has a set depth method. So I'm going to now be able to access that dot set depth. And then we'll do something like 3.3. So the only new stuff I had to write in my solid was get depth, set depth, constructor, and the new attribute. Everything else was inherited. So to demonstrate that works, we'll print out contents. So we'll do something like system.out.println s.getLength. And then you'll see that the value got assigned to it. Okay, so there's the 2.2. Now, what happens if I do get area? I can't invoke the getArea method because I inherited getArea from class rectangle. But look what is defined. Look at the logic in getArea. It only multiplies the length times the width. That's it. So it's not going to give us the true area of a solid. We're still calculating the area of a rectangle because of the way that logic was defined in the inherited method. And so there's the area for the rectangle. So there's the result of my getArea method, but that's only the length times the width. There's a third dimension that I have to work with, and that's the depth. So clearly this getArea method that we inherited from rectangle is going to do the job. So what we're going to do is we are going to override the inherited version. We're going to replace it. So we'll do something like this. We'll say public double get area. And so in here, what we'll do is we will return this dot depth times, and now you might be thinking, well, why don't we just do this times length times this times width? But is that going to work? No. As you can see, we got the red squiggles. Why? Because anything that is private in the parent class is not directly accessible from the child class. You still have protection there. And so private means private. Any class outside of the owning class cannot directly access private stuff. That includes the derived class or the child class. So we can't directly access it. But we did inherit the public get length and get width methods. So what we'll do is we will invoke those. So we'll do this dot get length times this dot get width. So that will return the contents of the length and the width, and then we'll multiply that times the depth. So if we go back to our main method, you can see that we set the width, we set the length, we set the depth, and now my getArea method, we overrode the inherited one, we made a new version of it, and that's going to calculate the correct area for us, which you can see right there. Now let's go back and take a look at this again. It's solid. Now I said that we can't do this length and we can't do this width because in our parent, it was private. Well, we can change the access specifier or access modifier up here from private to something else. If we made it public, well, public is public to everybody, and that would include the child. And so now you can see that it actually works. The red squiggles disappear. Problem with that is not only can your children access it, anybody else can access it too, which is generally bad, right? So there is another type of access specifier, access modifier that's kind of an in-between. It's kind of like a combination of private and public, and that is protected. So if we make these protected, then the derived class can access them. So you can see now that the squiggles are gone, and if we go back, we can run that and get the correct area. We're directly accessing our inherited stuff from the parent. Now, that's still bad because what if class rectangle had some input validation stuff inside of set width and set length that ensured that length and width only held a certain amount of values or a certain range of values? Well, since we have it set for protected right now, the child's methods could get around that. It could just simply do this length equals negative 99. And so we got negative numbers in there, even though maybe in class rectangle, we wanted to make sure that only positive numbers or non-negative numbers were assigned to length. So we could do something like if L is greater than or equal to 0, then we set it, otherwise not. If I make these things protected here, then my children can turn around and just get past that restriction. So if you set it up this way, this is what's known as a brittle class, because it's easy to break the parent class. Parent class is only supposed to have lengths that are 0 or bigger, but since we made them protected, the child class can get around that restriction. So it's still a bad idea to make stuff protected. So the best thing to do is to make them private. Now there's one other feature of protected, and that is in addition to the child class being able to directly access the protected stuff, items within the package can as well. So it's a little bit more permissive than the way other programming languages do it. So for all of these reasons, it's still a good idea to make the default here, to make your stuff private, avoid making the class brittle. So then that would mean that we would need in our solid to go back to making these guys use accessors, get length and get width. Okay, so one more thing I want to show you here, and that is the super keyword. And the super keyword is used for two things. It's used to invoke the parent class's methods, and it's also used to pass items up to the parent constructor. So let's change the constructor in my parent class to where it is no longer a default constructor and it has parameters. So we'll do something like double L and double W. And so then we'll need to set them in here, and then we'll do this dot width equals W. And then in our child class, we'll add a parameterized constructor as well. So we'll do double L, double W, and double D. So we'll use D to initialize our new depth variable there. So we'll do something like this, depth equals D, and then we'll use that super keyword and pass it a couple arguments. What are we going to pass it? We're going to pass it the L and the W. Now notice that we've got the red squiggle here. That's because when you use super this way, it has to be the first item in the constructor. So what this is going to do, it's going to take whatever we pass to L and W when instantiating a solid object, and it's going to pass them up to the rectangle. It's going to pass those values into here. And so you kind of got this chain thing going on. So that way the length and the width will get their values assigned to them. Now, if we go back to main, you can see that we've got the squiggles under the rectangle and under the solid. That's because we don't have a default constructor anymore. We have to pass some values. So we will do that. So for our rectangle here, we'll just do 2 and 1. And so the length and width of the rectangle will be assigned. We'll call the getArea method. And then for our solid, we'll do 2, 2, 3. And we won't do a set width, set length, or anything like that because we're using the constructor for it. And so what's going to happen? Well, in the case of rectangle, the 2 and the 1 are going to get copied into the L and the W respectively. And then those will get assigned to the length and the width. And then when we call it getArea, we'll skip the area for the rectangle. Now in solid, we're going to have the 2, and the 3, and then those will be assigned to L, W, and D. So the 3 will go into the depth variable, and then the other values will be passed up to the parent constructor via the super call. So the contents of the L and W parameters will then get copied into the rectangle's constructor parameters, and then those values will get assigned to the inherited length and width. So that's how super works. So then we'll see the different areas, right? 2 and then 12.0. So last thing I'll show you about the super is that we can invoke our parents methods using super. So let's say that I wanted to do something a little bit cleaner than this. Let's say I wanted to do this. I can say super.getArea. So this is saying invoke my parents' version of getArea. Now, what does my parents' version of getArea do? It multiplies the length times the width. Fantastic. We'll get that length and width out of this, and then we'll multiply it times the depth, and we'll still get the correct area. So you can use super in a couple of different ways. We can use it to pass values up to the parent constructor, and we can also use it to invoke our parents' methods. Okay, so let's finish up by taking a look at what the UML could look like for this. All right, so I have as my base class rectangle, and my rectangle has 2 variables. It's got 2 private variables. It's got a private length variable that is a double. It has a private width variable, which is a double. It's set up to have a constructor, which is public, and has 2 parameters, L, which is a double, and W, which is a double. And then we've got our accessors and mutators. So we've got set length, which has 1 parameter and returns nothing. We've got set width, which has 1 parameter, returns nothing. And then we've got a couple of accessors. We've got get length, which has no parameters and returns a double. We've got get width, which has no parameters, returns a double. And then we've got our getArray method, which has no parameters and returns a double. So that's what my rectangle looks like. Now, we also had our solid. So what does our solid look like? Well, let's add that into our diagram. And solid just adds a few things, a few new things onto rectangle. And that is a single private variable called depth, which is a double. It has its own constructor, which is public, and it has 3 parameters. It's got double L, double W, and double D. And so all we had to add here was an accessor and a mutator and a new getArray method. So we had set depth, which had a single parameter, which was double D, and it returns nothing. We had getDepth, which has no parameters, it returns a double. And then we had our own getArray method in here, which has no parameters and returns a double. Now, how do we denote that a solid is a rectangle, that solid inherits from rectangle? Well, that is where this arrow comes in right here. It's an open-headed arrow that points from the child to the parent. And so this is a complete UML diagram that represents the rectangle class, the solid class, and the relationship between them. Now, how do we denote that something is protected? Well, if we want to make something protected, then what we use is hashtags. So that indicates protected. And not only can variables be protected, but methods can be protected as well. So that's everything that I wanted to show you in this video. What did we take a look at? We defined what inheritance is. We saw an example of it. We saw how to diagram it in UML. We learned about the protected keyword. We learned about method overriding. And we also talked about how you can avoid making a class brittle. As usual, if you're a student of mine, you have questions about any of the content of this video or any of the other videos in our course, please feel free to stop by my Zoom office hours or email me via Canvas. Thanks for watching, and we'll see you next time.